Screw this. Well, at least the shed has heat. Let's get down there. Hello, shed. Hello. The process of setting up a milling vise is simple enough. You lightly clamp the vise down, you move the milling table backwards and forwards with a test indicator running against one of the vise jaws, and you adjust the vise until the test indicator doesn't move. It's really not that difficult and doesn't take very long. The normal method of doing it is to adjust the vise using either a fine universal adjusting tool or a coarse one. Coarse, fine. That's great, but I really don't like tapping or banging on anything that one of my test indicators is touching. I just don't like it. And I'm fed up with doing it, so it's time to make an adjusting tool. The best shop tools are made from rusty old bits of leftover material. There we are. Looks perfect. Although this is going to be cut into a couple of pieces, I'm going to start by cleaning up the whole thing, which I'm going to do with this 2-inch end mill, face mill. I'm just cleaning the parts up on all sides, just removing the rust and making the parts square. I was trying some WD-40 as a coolant / lubricant, and it did seem to help the surface finish a little bit. This piece was pretty out of square, so still some material to take off there. Take off another 10. See if that does it. Surface finish on these parts is better than it actually looks, but in retrospect I'd have been better off using a fly cutter, and I'll try that next time I do a part like this. What the hell? Good enough. Right, deburr this and try again. Make some changes to the setup. Surface finish isn't critical to this, but trying to do a decent job along the way. It looks in the camera worse than it is, but it's still not very good. Right, I'm just going to take a file to this. Right, I've changed over to a 1/2 inch end mill carbide this time, 4 flute. And let's see, I think this will be much more appropriate. So it'll take a couple of passes each side, but I think the surface finish will be better overall. So I've done the same thing. I touched off on the parallels to set the Z height, and I'm going to find the height of this and start off with just a 10th thou cut. See how that goes. If that goes well, then I'll increase the cut, see what I can do with it. Oh yeah, world of difference. Of course I knew that. Just like pushing things once in a while, see what I can do or not do. Right, deburr that, turn it over, and then we'll get to making the boss. Back again. So besides a bit of a cleanup, I've set up an end stop, because this, now that we've cleaned up, laughably, cleaned up all the surfaces, well, one remaining, it will be time to add some more features. So at this stage, I'll be milling away this material to make a step boss, and then we can come in and drill the through hole for the clamping bolt, and then turn it on its side to do the tapped hole for the jacking screw. And then I want to come back and do the same for the other piece. So we have a 0 established for the Z. Now we've got a stop position for this edge, and so everything else can be taken from that. And having talked through that, what I may do actually is do the 2 tapped holes as a second operation. I'll mill the step on both of them, then come and do the through hole on both items, and then do the tapped hole on both items. The reason for that being that I don't want to take this end mill out and then have to refine the Z. That's sort of the whole point. So I think that's a good approach. Doing it that way anyway. So anyway, now we need to make a boss 1/4 inches tall, 1/2 inch away from this edge, and roughly 1/2 inch long, actually 0.54, fit snugly in the table slots. So what I'm going to do is touch off on that surface with the end mill to establish location this end. And then what I'll probably do is plunge cut. It's usually quicker to plunge to take away bulk material rather than go backwards and forwards. You'll see what I mean. Plunge cutting like this is by far the fastest and easiest way of removing bulk material. So I do this, leave rough edges with a few thousandths on, and then come back and clean them up afterwards. Now for clearance hole for 3/8 inch bolt, and going to do both blocks and then put the blocks in for the tapped hole. Zero was already established on the back face of the vice jaw and on the basis of the stop there, so now it's really easy to reposition this in this orientation and drill the pilot hole. I've just moved the DRO to the right position and away we go. Didn't move the DRO at all. I've moved the table to the right position, locked it down, and now away we go. Rather more anchor lube there than was necessary. That's a waste, don't like that. Right, deburr, and these are done. Here I'm making a pair of adjusting screws, and I'm just turning the diameter of this down to 3/8 of an inch in readiness for single pointing the thread. The thread is a 3/8 24 UNF thread, and although I do have a die to do this, I'm single pointing the thread for the practice. Here I'm using the upside down tool method so that you cut the thread by cutting away from the headstock, which does reduce some of the drama involved in this. I measure the pitch diameter of the thread with a thread micrometer just to make sure that I actually get the thread cut correctly and that it falls in the middle of the range for the class 2A that I'm trying to achieve. Using a follow rest here just to support the end of the screw while I machine away the very tip of the screw that was used to support the part on a center while cutting the thread. Setting the parting tool height on center using a tool which I'll show in another video, and now parting off the adjusting screw. So I just did a really crude zero set, just bumping up against the edge of the end mill because this is really non-critical. What's more critical is the size of the hex, which is going to be a ½ inch across flats. So what I will do is bring the cutter down just till it touches on the top of this, which I've measured at 5/8, and then bring the milling cutter down accordingly and shave off material. And we've got to take 63 off each side. Right, so spin indexer is set at the 0 position, so all I will do is index around 60 degrees at a time and machine 6 flats. Seems simple enough. Yeah, did wonder about that. I don't have enough clamped in the indexer, so let's fix that. That's better. I decided to add a small Tommy bar to these, so here I'm just finding the end of the part and then finding the center line with the spin indexer clamped in the vise on the machined faces. After this video I went and cleaned off the edges of the spin indexer that are facing us here so I can clamp it in any orientation. So here I'm just using a center drill to spot the position of the hole. And then come back and drill the through hole. And checking the hole size. Flats were aligned just using a square. Just cut off a couple of pieces of stainless rod. Not sure what diameter these are. 4mm. And I'm just going to round the ends over, make them nice, and then tack these into the adjustment screws. This is a simple high-speed steel form tool just being used to put a slight radius on the end of the part. A small fuse tack is used just to stop the tommy bars from falling out. Let's have a look at the setup of how you use these. Pretty straightforward. The block is clamped in place using a T-nut, stud and nut. The vise is clamped down here so the screw is able to apply a moment, and you use one adjusting screw either side. And in this way you can push on both sides of the vise as you tram the vise in and get it trued up very quickly. Let's take a look at that. Right, let's see if we can demonstrate how these work. Here's my delightful Kurt vise, and it should be out of tram. We'll zero the test indicator. Now the divisions are 5/10 of a thousandth of an inch, and if I, there we are, if I move the table, you can see it's way out. Now let's bring it back here. Now you can even do this by hand. I mean, you can twist your vise, and the idea is that you scan the table and you adjust the vise until the needle stops moving. That can be a little bit difficult to do, turning the handle and adjusting the vise and tapping it and banging on the vise and shocking your indicator. So another option is to use your power feed if you've got one. That makes it a bit easier. Just turn it slow. And you can tweak your vise until it stops moving. But with the screws, It's just that much easier. See, I'm about there. And pretty quickly we get it to a point where it's barely moving, and if I keep going I'll get it dead on. But I think that demonstrates the point. It's really easy to get a fine adjustment and get the vise in. Now it's not like these are essential. You can move it by hand, tighten it down, you can tap it with your fine universal adjusting tool, whatever is your preference. I'm super happy with these. This was the easiest adjustment of a mill vise I've ever done. And the idea is that I will actually use these for some other things, probably add some other holes in this as I go on. Obviously you can use them to adjust anything on the mill table, and use them on angle plates and so on to trim things in. I just find it a lot easier to get things really true using fine threaded adjustment screws. One of the other things I want to use these adjusters for is tramming the head of the mill. Made them wide enough so that I can add some holes and then add some tapped holes to the mill so that I can have these either side and tweak the angle of the head. Because right now it's such a pain in the proverbial to tram the head in that I don't ever take it out. And it's a shame, because having the rotating head gives you some capability that's potentially very useful. So being able to tram it back in easily would be a huge benefit.